All right, so what we're going to do now that we've talked about the domain of radical functions, we are going to look at the transformations. So again, we have done extensively the different transformations with graphs throughout this course. The only difference here is I need to take my radical function and put it in a format where I can understand what is being done to it. We cannot say that this graph is moving to the left 36 units. It's not in the proper form. So whenever you're asked to graph one of these and then find the domain and range, whatever else, here's what you're going to do first. We're going to take what's under the radical and we're going to factor out what's ever in front of the x. So I'm going to factor out that 9. And when I factor out a 9 from 9x, that leaves me x. When I factor out a 9 out of 36, that leaves me a plus 4. One more step, and then we're going to be able to see how this graph is transformed. I'm going to now take the square root of 9 by the product rule of radicals. So the square root of 9 is 3. Now it's outside the radical, and I have x plus 4. So now we can see there's two things happening to this graph. Maybe pause the video and write in your notes what you think the two things are. And now when you push play, the first thing is that the plus 4 right there with the x is going to move the whole graph left 4 units. And then the 3 out in front of the function means I'm going to multiply my y values by 3. There's going to be a stretching factor. So I'm going to do both of those things. On my graph board right here, I have the square root function graphed. And so we're going to do these two things. We're going to multiply by 3, and then we're going to move the whole thing left 4. And as I've told you before in class, what I would encourage you to do, if you need to do this in 2 steps, that is great. Step number 1, let's multiply those y values by 3. And then step number 2 is we'll move the whole graph left 4. So first thing, this y value here is 0, so it stays 0. This y value is 1, so 1 times 3 becomes 3. This y value is 2, so 3 times 2 becomes 6. And then this y value is 3, so 3 times 3 becomes 9. And so I'm just going to do this dotted because this is not our final graph. This is just a nice intermediate step. That is, right here, 3 times the square root of x. And now what I'm going to do is I'm going to take that whole graph, just like we saw on our transformation, and I'm going to move the whole thing to the left 4 units. So here we go. This is at 0, so 1, 2, 3, 4, make a dot. This is at 1, so when I move 1, 2, 3, 4, I'm going to make a dot right here. This is at 4, so when I move left 4, it's going to go 1, 2, 3, 4 to right here. I believe 1, 2, 3, 4, 5, 6. Yes, that's the right place. And then this one is at 9, the x value 9. So when I move it back, 1, 2, 3, 4, it's going to go back to about 5. And so here's my graph. Woo-hoo-hoo! And this is 3 times the square root of x plus 4. From the graph, we can find the domain and range. You could have found the domain analytically. So this starts at -4 and goes to infinity. That is my domain. And you can see since I have not moved the graph up or down, the range remains a low value of 0, and it goes to positive infinity. And there is my transformation of a square root graph.